And if somebody has no audio, you could type it in the chat. Sometimes the Teams doesn't work very well, so you might be able to be on with your laptop or PC and see the screen. But if you can't hear, then the invite has a phone number, so you can log in with your laptop or screen share, and then you can call the 800 number for audio. So have you typed that in, Justin?
Yes, I'll type that in. Yep.
So I'll go over the fiber characterization kit. Many folks have been working with fiber for a long time, but that usually means an OTDR test or a power meter and splicing or doing the traffic across the fiber. And then we go to higher speed transmissions, commonly 10 gig or 100 gig. We hear the term dispersion, which is polarization mode dispersion, and CD, which is chromatic dispersion. So you might have been working with fiber for a long time, never heard of these terms, and then all of a sudden somebody says to go test it. But the setup for PMD is auto, and the setup for CD is auto. And they just spit out numbers, so it's more of a digital test. I think doing PMD and CD is easier than doing OTDR or power meter. If anybody has any questions, I can give you the 30-second definition on PMD and CD. A lot of times, if you know what you're looking for while you're doing something, it just makes the testing a little bit easier because you understand what you're doing. So if anybody wants that, let me know, and we'll make sure we give you the basic definition of PMD and CD. I tend to skip.
Hey, can you go ahead and do that for the techs are on here, because we can't assume everybody's at the same level, and there's probably some people that haven't worked with it.
Okay, thank you. And then if some folks have done it, it just spits out a number. So just not that bad. Because one time I said, hey, we're going to do PMD today, and somebody said, you're talking over my head. And I said, I just said 3 letters. So I gave you the 30-second class in 2 minutes. We can talk about ORL, OTDR, loss, inspection, anything else like that. But certainly the new one tends to be PMD and CD. So CD is chromatic dispersion. And basically it means, I call it color dispersion. We can call our invisible light a wavelength or a color, but I equate it to putting a Ferrari and a Humvee on the road, the highway. The Ferrari is simply faster. So based on the frequency of your wavelength, the different wavelength travels at different speeds. So when we say we're shooting traffic at 1550, there is a width to that laser. So on this left side, we see red, yellow, green, blue, and that's 1550 because there's some width to it. So when we say 1550, there's some 1550.000 something and some 1549.000 something. So it's just not one color at 1550. It's a bunch of colors that are very, very, very close together. So when we shoot that 1550 down the fiber, the fast colors get faster, just like a Ferrari over a Humvee on the road. So on the right side, we now see that spike is lower. So that's loss. We came in hot. We go 10, 20, 30, 40, 50 miles, and now we have less power. And then now we see the colors spread out. So if you go a mile, the Ferrari is going to be in front of the Humvee. You go 2 miles, the spread is going to be even more. So dispersion means spreading, and I call chromatic dispersion color spreading, because your wavelengths aren't just pure 1550 or whatever wavelength it is. If it's DWDM, it's got some width to it, so it's made of more than one color. So those different colors travel at different speeds. So when you shoot a 1550, a digital one, it's going to spread. We've always had dispersion, but in the old days of OC3, OC12, OC48, or gigabit Ethernet, the ones and zeros are far enough apart that they don't spread and bump into each other. When we go to 10 gig or OC192, or we increase the distance on the fiber, then all of a sudden ones and zeros can bump into each other. So this is just a mention of it. If you do this for a while, you can tell your fiber type based on the numbers that you get. We in the field as techs don't have to worry about it. We just turn in the number and let your network equipment manufacturers or your transport engineers or your traffic engineers, somebody worry about these numbers. For CD, technically it can fail, but it can be fixed. So I said a Ferrari is faster than a Humvee on the highway. So if we're racing and I'm in the Humvee, I'm just going to lose on the highway. So I'm going to have Justin flag that Ferrari into the woods on a dirt road. Now the Ferrari is slow on a dirt road and the Humvee can catch up. So on the highway, the Ferrari is fast. Then we put some fiber or an element on the span, and then it lets the Humvee catch up. So fast on the highway, Humvee catches up in the woods. And then that's what your network engineers do, or the network equipment manufacturer. It could be a dispersion compensation fiber, a little card that goes in your rack, and it might have 10, 20, 30, 40 miles of fiber in it. So the fiber is now becoming mud fiber instead of highway fiber. So if glass is pure white, they can put some chemicals in there that make the different colors speed up or slow down. So if you hear DCF or DCM, it's dispersion compensation fiber or dispersion compensation module. And it's just taking the slow guy and speeding him up, taking the fast guy and slowing him down. So all your colors travel down the fiber at the same speed. And if they don't, this is going to correct it. So any questions, comments on CD?
So this has to be done. So once you get the numbers, then engineering will decide what modules we need put out there for the new transport.
Yeah, exactly. You and I just turn it in. So CD could always be fixed. So if you don't have to put in a pass fail, that's great, because usually red or green is bad, bad, bad. So if they give you a number to put in, then we can make CD or PMD be red or green. But if it's red, it's not going to truly fail because they can fix it. So one way is through these little modules or cards. But the second way, 100 gig, 100 gig has expensive lasers and receivers, and they have digital signal processors in them, DSPs, and it's just a computer type card, and it can look at these signals, do a bunch of calculus, and say, hey, I see a lot of CD on here, but I just compensated for it and I just fixed it. So those, your engineers or the network equipment manufacturer know if they have to do anything, or if they know if the numbers are good.
Great, thanks.
So all we got to do in the field is turn in the number. After you do it for a while and you see the numbers, sooner or later you can get it memorized, or you got them in green and red. Polarization mode dispersion, PMD. It's got the word polarization. So apparently light is polarized. So suntan commercial, it says this suntan lotion protects you and I from ultraviolet A and ultraviolet B. I thought it was sunlight, but technically it's sunlights, because you're just not getting hit by sunlight. You're getting hit by sunlights, the A and B. And if there's two different polarizations in light, there might even be more. It looks like the A and the B is the one that hurts us. The other one is we have polarized sunglasses. I saw them a long time ago. The towel on the table was pink. I put glasses on it that changed blue. Inconceivable, you say? Well, if light's polarized, those glasses block some poles. So if blue is made up of 3 different poles and those glasses block 1 or 2, it literally changed colors. So what that means is if we draw on the whiteboard a 1550, right? We're looking at it, it's vertical, it's just one 1550. Well, there's 1550s that are coming out of the whiteboard, up, down, left and right, in front of the whiteboard, behind the whiteboard. So in this picture here, they just have two poles. One is going up and one is horizontal. Well, when we go in fiber, it's not perfectly circular. And as those different poles hit these different angles, it makes one of the poles slow down. So I equate this to a train track tunnel. You and I are both the exact same speed. We go in the tunnel with no flashlight and you're on the tracks. So you're pretty much going to be going straight and you're just going to be hitting left and right because you're going to hit the rails. You're going to stay in the middle of the tunnel. Well, I'm a different pole. I'm not on the tracks. I'm off to the tracks. So sometimes I hit the track. There's puddles in there. There's trash. Then I put my hand on the wall. Then they got those little hideaway nook and crannies. So I'm going in the nook and cranny with my hand. But even though we're going at the exact same speed through a tunnel, you're going to come out in front of me because you're going mostly straight, just zigzagging on the tracks. And I'm not on the tracks and I'm going left, right, up and down, hitting the wall, hitting the tracks, going in holes and taking a different route, which makes me have a slower arrival time. So same way, if you don't like that, PMD, light is polarized, you're shooting 1550A and 1550B. And there are different orientations. So they're just going to take different routes down that fiber and come out at a different time. So now in addition to CD spreading, we can have PMD spreading. So any questions on that for the attempt at a short class of PMD? And if you don't like that, it just spits out a digital number, puts it in a report, and then we just turn it in. These are for lower speeds. So depending on your traffic type, you may be told to put pass fail in for PMD and CD, or you might not be told. Because at 100 gig, there's 100 gig that can handle high PMD and CD, and there's 100 gig that can't handle high PMD and CD. So we turn in the number, and if they want you to have pass and fail, they'll give you the pass and fail so we can put them in the tester, and then you get stuff in green or red. If there's no pass or fail, then your numbers just come out in black. We turn them in. So that's the attempt at PMD and CD. Any questions on the other more traditional testings like OTDR, loss, ORL, and that kind of stuff? So the one thing I'll show here is fiber characterization is just a generic word. Somebody said they had to characterize the fiber, and it meant they just need a power meter to look at the light levels. So for you, it's a specific suite of tests, but we just got to be careful. People say the word certify, and in the enterprise space in building data centers, there is a technical term called tier 1 certification. So somebody may say, I need to certify my fiber, and like, oh, I need a tier 1 certifier. But for you, when we say characterization, we actually mean the full suite of tests. I've seen characterization mean, oh, I just need an OTDR. I just need one-way OTDR. I need two-way OTDR. So in your case, it includes all the tests. One, everything's got to be clean on your network, jumpers, launch cables, and the test ports. If the tester or launch cable is dirty, expect ORL to fail. ORL is caused by high reflections. We have traditional insertion loss, source and power meter. We have traditional OTDR. We have ORL, that means optical return loss. It looks at all the reflections that come back to the source. So OTDR looks at the individual reflection of an event. Patch panel as reflection, launch cable as reflection. That's individual reflection. ORL looks at all the reflections coming back. You and I don't like to drive in the fog with the high beams on. So 10 gig and 100 gig doesn't like back reflections either. High beams on in the fog, comes right back to our eyes. We can't see very well. So high-speed transmissions of 10 gig, 100 gig don't like reflections coming back to the source. And then we add PMD test and CD test. So here's a schematic of the kit, a T-Bird 8000 on one side and the T-Bird 6000 on the other side. And for all this stuff, we have this recorded, we have quick cards, we have videos, and we have the 800 number. But one unique thing about the T-Bird 8000 is the MTOW. We call it a multi-test access unit. I call it a switch because what the heck is an MTOW? So we connected the fiber under test, and when we use automation, the switch switches back and forth automatically. So with traditional methods, you'd have to connect to an OTDR, connect to a loss module, connect to a PMD module, and connect to a CD module. And at the other end, you might have to do 3 connections. So you might have to connect to 7 different modules. With this, we can connect to the fiber under test once and do all those tests. So we have the MTOW, then we have the OTDR module, which is also a true insertion loss module and a true ORL module. And in the 8000, we have the dispersion module, which tests CD and PMD. And the far end on the 6000, it's a very dense tester because the OTDR, the true insertion loss, and true continuous wave ORL, and PMD and CD source is all on one module, which means it's all on one port.
Question.
T5, yes, please.
What if you don't have this model, the 5000 or the 8000? I've got the E126A.
Okay, so if you just have a OTDR, that's just the OTDR. So if you have that, it's great. But if somebody said, hey, you got to go do PMD and CD, then you could use whatever language you want with what. So this is set up for the full suite of tests, but you may own OTDR onlys, scope onlys, loss tester. So in your case, if somebody says do PMD and CD, you're not going to do it with just the OTDR module. You'd have to get a kit. Sometimes they're shipped, sometimes they're in a market and somebody's at Northtown, Southtown, or there's bordering towns. So, right, you can't do PMD and CD if you don't have that module. And Justin, do you have any input? Like if I'm in a big town or area, there's one kid or some other folks, if they've done tests, and they might know that they share them or ship them or drive them.
Yeah, so this full bidirectional fiber characterization kit was, there's pretty much 2 per state, just recently purchased here. So, and there was more than that with OTDRs, with traditional standard OTDRs. But the FC kits were, for instance, there was 2 going to New York, 2 going to West Virginia, to Ohio. So it's definitely more of a shared kit here for sure. Or here in Texas, there's a team dedicated to do all the fiber characterization. They do it for the whole state. So I don't know. I'm not sure if that applies in the rest of the country here or it's a shared. But yeah, this is a specialized test for sure. Down here, they do it for 10 gig circuits and above.
And the reason for that is if I go from 1 gig to 10 gig, there's 10 times more ones and zeros within a 1 second time period. So if a digital 1 spreads, it's more likely to bump the digital 1 that's next to it. So that's why you may have had that OTDR for years. Boy, I've been doing OTDRs for 5, 8, 10, 12 years. Now all of a sudden somebody drops PMD and CD on you. So if somebody did give you a kit, shipped it, drove it 4 hours away or 2 hours, they drove it or they shipped it to you, then we'll do individual webinars for sites, but then we have the quick cards, the videos, And then what I do if somebody's got a test tomorrow, I say just put it on the tabletop, put in your job info tomorrow, and run a couple practice tests just so you can get used to the flow of connecting to the fiber under test once and running all of these tests.
Okay, well, the reason I asked because it has certification menus in it.
Right, but if it's just a OTDR, it's just a OTDR. It's not going to do the additional tests.
Okay, just making sure.
Yep.
Yeah,
and
yeah. So Frontier has hundreds of that kind of OTDR that just is a basic 1310 1550 non-dispersion tester, and then this kit is got such much more capability to it.
So it'll vary by area. Sometimes they have one or two teams they want to be the specialist because they're senior or they like this stuff, and that way they're going to say you're going to do most of it, or sometimes they'll just pick anybody at any time. But when you go to PMD and CD, I call it the IROPI. That's increased responsibility without pay increase. You're now the PMD and CD tester. And because it is automatic for PMD and CD, fairly easy test, but you don't even have to spell PMD and you still can crank out a PMD test.
This is Lynn over here in Crossville.
Hey.
We about 4 years ago, I have the T-Bird 6000A, and that module, we called and got a price on that to add to that 6000A, which would do that characterization. And 4 years ago, that module was $49,000 just to add to that 6000A to do that. That's part of the reason why everybody, you don't have one everywhere.
That's exactly right. Yes. This kit is far more capable than regular OTDR, much more capabilities, and yeah, we give Frontier our best price possible for sure, but they're still for this kit, this round it was above $60,000 for the whole thing.
So here's one unique thing that can be done is traditionally we connect to a fiber under test. So it says fiber link, but then there is a data link connection. So that's the yellow fiber. On the top of the mainframe, there's a port that says TS. It means talk set. That is a data link fiber, and that sends commands back and forth between the machines. So if you and I are to enter the fiber and we want to do OTDR at the same time, mine would say signal detected because I see your OTDR, and yours would say signal detected because you see my OTDR. So what the data link connection does, it says, Mike, do OTDR, Lynn waits. Then it says, Lynn, do OTDR, Mike waits. And then it says, Mike, you be the PMD source. And then it tells the switch over to the PMD module. And now we're going to do a PMD test. So that's full automation. If you only were testing 2 fibers, you don't even have to use it. Then you go semi-automatic. So you just connect once, but it's just a little weird. Normally we connect to 1 fiber. You see 2 connections here. If I had to test 12 fibers, I put fiber 1 as my first fiber to be tested. And then if I'm testing 12 fibers, I'll plug into fiber 12 for the talk set data link remote control fiber. And then once you get to 12, then you put your fiber under test to 12, and then you put your data link remote control fiber on another fiber such as 11 or 1. So on the T-Bird 8000, it's up top next to the power meter and VFL. It's going to have a Sam Charlie UPC connector on it. And the 6000, it's the same thing up top. Sam Charlie next to the power meter and VFL. With the switch, we got these 2 little tiny blue jumpers. The A port goes to the OTDR, and the B port goes to the PMD and CD module, which says dispersion. So when you put this in the hard case, which got the handle and wheels, you leave those connected. Cleaning is a pain. Stuff gets dirty overnight. Then the dirt moves around and it doesn't come off. So you leave this stuff in connected, it's clean, and you don't ever have to disconnect it, and it saves a lot of time. On the T-Bird 8000, you can leave your launch cable connected as well. So that's going to go on the MTOW switch. Notice it says COM. That's the common port. It doesn't mean communications. It's COM for common port. So you plug into the switch, and then the tester switches back and forth between A and B automatically. So I leave my launch cable connected as well. Now I just have less connections to worry about. On the T-Bird 6000, if you leave the launch cable connected in the case, you have to cut a little hole because the side of the T-Bird goes up against the side of the phone. Well, inspection is time consuming, a little bit hard. So I cut a little slot in my T-Bird 6000 so I can leave my launch cable connected. The top is blocked as well for the 6000. I've seen one person cut out room for it, but if not, you can take off your little jumper for the talk set data link connection, and then now you just have to have one little jumper connected to get your talk set port going. And then this is interesting or unique. This is the automation page. You pick the test you want to run, and you enter your job information, such as I'm at Northtown going to Southtown. I'm at a CO downtown going out to the ring. You put in your information, and then when you hit start, it runs all the tests automatically, and you get a summary page. So you see some green and red down there. It'll say CD, PMD, loss, ORL, and length. So before you even go to any results page, you can see that loss is good, length is good, PMD and CD are good. And then you either have stuff in green and red for pass or fail, or you don't do that at all. If we use that second fiber, that data link fiber or talk set fiber, then it takes the far end trace and sends it to the near end machine, which is 8000. So here, this is made on the machine in real time. I can see my trace. So here it says SHD, that's me at the A end. AUR is the B trace, and then A to B is a combo trace. So there's no events because this is just a reel that we buy online. So it was just 50 kilometers. So now you have the butterfly trace or the X trace or the BIDAR trace. We call this an OEO because it's done in real time. That means origin, endpoint, origin. My tester at the origin, the A point, goes to the endpoint, which is the B or Z point, and it takes it and sends it back to me at the origin. So if you hear OEO, that's not a standard industry term. It's something that we use to say your trace comes to me, and on the T-Bird 8000, I see both traces displayed at the same time. And that only happens if you use the talk set port, the data link port. Traditionally, I do a trace, you do a trace. Then they get sent to me, and I got to put them together on a laptop using software and make this report. And I did that yesterday with somebody. He sent me traces from each end. I'm like, your fiber numbers are different. You got different names, and they're all called A to B. You got an A to B trace and a B to A trace. So his was a mess. I had to fix them all up. Luckily, the traces were good, but sometimes they're bogus traces. Why did you keep shooting? These are all horrible traces. You should have made some changes. So now, before you leave, before you even go to the next fiber, you're going to see both OTDR traces automatically. So we try to minimize the technician touch because we connected the fiber under test once, and then we combine all the test functions, right? That T-Bird 6000, somebody had an OTDR. What's the OTDR? PMD and CD source, true insertion loss tester, and true continuous wave ORL tester. And then we can save everything into one report and name it. So if I have to turn in a report, I can go to the PC and do it. But if my PDF, if I test 4 fibers, has 4 PMD, 4 CD, 4 bidirectional OTDR, 4 insertion loss, then no work is required for report creation. If we use that talk set port, we have full remote control of the far in. And if we don't use it, then we have semi-automatic. Semi-automatic means it'll say, Mike is doing OTDR, wait till he's done. Then I hit a button and it goes and tells Lynn, Mike is done, now you start your OTDR. And it'll say, tell the far end guy to turn the PMD source on. So that's semi-automatic. Little messages come back and forth, and then it tells each of us what button to hit. So BIDR OTDR, if it's full automatic, no bogus file names, no bogus traces, no misnumberings, no lost files, because it's all done automatic. So we connect to the fiber under test once, and then we can use that data link port. AP is an attenuation profile test. I don't believe that's required for these guys, Justin, but if somebody ever wanted it for DWDM or ROADM, it's just not loss at 1550. It's a loss across a spectrum. So you could get loss at 1550, 1551, 1552, etc. CD PMD has a coefficient, so I use the Ferrari and Humvee. If the Ferrari is going twice as fast as me, in 1 mile, it's 100 feet ahead of me. In 2 miles, that's 200 feet ahead of me. So it's based on distance. We take the OTDR distance and we load it into CD and PMD. Traditionally, that's a manual insertion where people have to go and enter the distance. So if your distance is wrong, your coefficient is wrong, you don't even have to worry about that. I didn't mention it, right? Because it's all automatic. Now when the network engineers or your network equipment manufacturer engineers get CD and PMD, they got the total number and they got the coefficient. I mentioned the jumpers are protected because they stay in the travel case. So now when you take the T-Bird 8000, it's ready to test. I just check the end of my launch cable, check the end of my data link fiber, check the patch panel, and plug it in.
Hey, Mike, quick
Yes.
comment on AP. So right now, the network equipment manufacturer that's requiring the PMD and CD is not requiring AP attenuation profile. Could that change? Sure, that could change down the line, but right now, that is not a requirement.
And the reason why it might is if we do DWDM, we're typically in the C band, 1535 to 1530 to 1565. We're pretty close to 1550. But if we start getting out to 1565 and into the L band, the loss out there starts to get a little bit higher. So if those transport engineers or network engineers want to worry about amps and how the traffic's going to look, now they can get that loss test to say, okay, loss is good at 1580, loss is good at 1600, or they might have to worry about tweaking their amps a little bit. So with these bullets, all results are viewable on the T-Bird 8000. So if I'm using my remote control fiber, I don't even set up anything in the T-Bird 6000. I got their loss results, I got their ORO results, and I have their OTDR all on my machine. Some people do it because if I'm entering the job info on the T-Bird 8000, if they do it on the 6000, then it's just a way of talking back and forth. Okay, did you enter Northtown? Did you enter that as cable 123 ABZ? Did you enter the correct locations? But it's not required on the T-Bird 6000. I do nothing. But if you're working back and forth to talk to each other, okay, I just went to location Delta. Make sure you put Delta on your tester. And if we use that second port, the remote operation, then everything is automatic. So normally if I'm doing OTDR, I got to wait for you to be done. If I want to do a two-ended test, I got to tell you to turn a source on for CD or a PMD. Well, this sends commands back and forth, so it's all automated. And I mentioned you can get that auto report. So we have a quick card We have videos. I think there's 7 of them. And Justin, those are posted. So did you say they're posted so they can see them?
Yeah. I will. I'll post a link to the your YouTube channel in the chat here, and share it with all the materials after the training. But there's already one posted. There's an ONX training posted in there for the copper folks, and we'll get this one up, if not later today, certainly by the end of the day tomorrow.
So the videos, it'll have a title. Many of them are 3 minutes, maybe one is 5. And then I have a tips and tricks video. I think that's 9 minutes. And that just covers anything and everything about warnings. So if I look at the quick card, if we're inspecting, it tells me the exact buttons to press. When we go to run a test, here we are plugging in to the COM port on the switch. The 6000 port is on the side. That's the OTDR PMD. And then we'll have a picture of connecting to the network. So we already saw this in the presentation, but right, who wants to go look at a webinar to find stuff? You pull up the quick card. And one class, they plugged these yellow and red fibers in the wrong ports. He plugged his test port into the talk set port. I said, you don't have continuity, you're on the wrong fiber. He says, oh, I remember you saying don't do that. But we saw there was no continuity, looked at the fibers, we were just plugged into the wrong port. And then everything else is just a buttonology. Into the job info you want, hit start, and you're testing. So quick card, videos, the 800 number, and then through Justin or the sales team, maybe we do a second follow-up webinar, excuse me, for a site, or people just send me results. What do you think of this? I'm like, hey, those are valid tests. And oh, by the way, PMD and CD look good, or those are valid tests. But if you're doing 10 gig, your PMD is a little bit high, then we'll see what your engineers do. So any questions right now?
Yes, I got one. When these new pieces of equipment are deployed, I'm down in Lower Alabama and got about 2,500 square miles of fiber scattered through it. Is there any way that the manufacturer could do like an on-site training when this equipment gets here? That way it'd be more of a hands-on and you can learn your network and see what might be going on with it.
Yeah, it's possible. We'll check in with Justin on that. And then sometimes we do virtual and on-site. If we're coming on site, I still like to get a virtual. If we have supervisors or managers on there, then we know what's going to happen. People are prepared when we show up. So it just varies. Some folks are like, hey, you got to test tomorrow. Or somebody calls me from the job site, then bam, we got 10 minutes or an hour to get folks up and running. So we can go the different possibilities of making sure folks are supported. And then if it's tabletop, we just bring a reel of fiber. Or the flip side is I've been at a CO and somebody will go and put a loop back out. So we got fiber going out and back. And then now we got the two machines side by side. So normally we're at the end of a span, but if it says a loop back, the end of the span is side by side. So now people can practice both machines. We got 2, 3, 4, 6, 8 people. We put people up in pairs. You test, you test, you test. So we can figure all that stuff out as it goes on. The other thing is, if somebody had this class today and like, oh, I understand that it's fine. Commonly they'll forget by this afternoon or tomorrow, but a lot of times they don't got to do this for 3, 4, 5, 6 weeks. They're like, I don't remember anything. So then we just got to start from scratch again.
Hands-on is a whole lot better, especially when you can throw a problem in there and then discover it or fix it or, do what you have to do. I was just asking because I know there's some managers on here and maybe we can get something like that set up once all this equipment's deployed out.
Yep.
Yep,
And
for sure, Sam. So on the West Coast, they started doing this testing about 6 months ago. And, we took the same approach here. We had Mike go through remote training with as many people as possible. And then we coordinated a week where we did a class in the morning, a class in the afternoon, and went through 6 different locations. So it is certainly something we offer and would love to do, and just takes some coordination to get as many people trained as possible in a week. So yes, short answer, yes, and we'll follow up with the logistics of that for sure.
Yep. So we started with the virtual and then we went on site. I think the virtual helps. Like the one class I went on site and it was a different company and I said PMD and the guy said, you're talking over my head. Well, had I given him a virtual class first, if he didn't like my ultraviolet A and ultraviolet B to explain PMD, at least he would have heard it. I'm like, hey, PMD is test auto. You hit auto, you hit start, it spits out a number. You don't got to spell PMD. So a lot of times a virtual just helps folks get prepared. And then we'll say, hey, we're coming to do hands-on. So we want the machine out. We want it battery plugged in, charged up. We want fiber available. We bring test boxes, but if you do a loop back, that's fine. There's other times we say you drive, and usually it's short, so we don't got to wait an hour for driving. So then they'll actually be at the different end. And then the other possibility is we don't even have any fiber available, but they just hook up a little 3-meter jumper so they can say, wow, I got to do this, this, and this, and this. And then that's some practice. So even if I just have one span, I'll test it 3 or 4 times. I can see there's repeatability and consistency in the results, and it just lets me know, okay, let me say I got 3 to test. It's only one fiber, but I'll call fiber 1 job A. Then I retest the same fiber, call it job B. Test the same fiber the 3rd time, but call it job C. So between videos, quick cards, on-site webinars, phone calls, emails, post-sales support, we get people doing the stuff even if they can't spell PMD.
Okay, well, that's great to know. I probably got some fiber down here that'll blow your machine up because it's still got tree bark around it for a sheath. It come over on the arc.
Yeah. So,
all right.
Mike, one thing I'll share for our Frontier team is what's driving most of this in the purchase of the equipment is the HBE rollout with that high bandwidth Ethernet that's doing 100 gig links for various parts of the company. And so we have a rollout by state of kind of where they have that planned. So as we come into different states where that'll be happening, what was described by Justin and Mike will happen. Like for 2022, the states that we've got going are California, Connecticut, Florida, Indiana, New York, Texas. In 2023, we'll add a couple more states that'll have them planned, Indiana, Michigan, Ohio, Pennsylvania, West Virginia. So it's kind of a staged approach. And so this is really just trying to give everybody an awareness that as this happens, we've got the equipment there, it'll be shipped to the area, we'll have people trained and be able to do that, training in support of what's needed for that HBE rollout.
Thank you. But if a homeowner can get 1 gig and a business can get 10 gig, as the endpoints are getting higher bandwidth, then the network's got to have higher bandwidth. So you may have been the OTDR part meter person for 5, 8, 10, 12, 15 years. And then right now PMD and CD, that just tells us without knowing any details, your bandwidth, the speeds in your network are getting higher and higher. So that's when the network equipment manufacturer says, you got to give me PMD and CD results to make sure the fiber can support this. And a lot of times PMD and CD are still good or they're fixable, but we got a traditional bad splice, misrouted fiber. Your 50-mile fiber stops at mile 18. There's dirty connectors. There's bad ORL. So we have our traditional tests and traditional issues that many of you will already be familiar with. And then we add PMD and CD. But once again, not so bad because you and I aren't going to fix PMD and CD in the field. We turn it in and let network engineers figure it out.
I have a question also. This this 6,000 that I have, I do it when I actually do the test end to end. Is there an industry standard for like the reflective loss when I'm doing an events? Let's just say from 1 gig to a 10 gig. I know it can't be the same, but is it? Let's just say a neg 50 reflection. Do you go after that to try to bring that down, or is it like neg 35, neg 40? Is there an industry standard that will cause that to that can correct that and possibly get that to pass?
So there's industry standards. So here's some. If I pick TIA, it says reflection is a neg 35. If I pick IEC, it's a neg 35. This standard has no reflection. So one time I seen a provider say we got to have a neg 55 for a UPC. Well, I would say a brand new good UPC used to be neg 50 to neg 55. Well, they were just failing everything because it's hard to keep fibers perfect and have them plugged in perfect. And then they moved down to neg 45. So I've seen neg 35, I've seen neg 40. And then the other possibility is if we say it's neg 55, which is extremely tight for a UPC, then everything is failing, but we're just using them anyway. So it just comes down to personality and culture. Hey, if you make it neg 35 and we expect most to be neg 50, then we're going to have almost all of these pass. And if something's failing in neg 35, you better go clean it. If it's permanently damaged, replace it. But if it's neg 55 and everything is failing, we just tend to start forgetting about fails because it's hard to get every UPC to be neg 55. So if I'm in the field or with you and they don't tell me the pass fail, then I set alarms to no, and then I turn in results. But then if I see a negative 18 connector at the patch panel, I'm like, that's horrible. It's right there. You and I can clean that. There's a mud pie, we clean it, and then it goes to neg 49. So if it's right there where we are at either end, we can look at it, clean it, get it to pass. If there was a connector out in the span 30 miles away with a neg 18, whether it's pass or fail or not, I'm like, that's a horrible connection. 10 gig ain't going to work. 100 gig's not going to work. So it's just always arguable. Basically, if you tell me what you want, then we would put it in there for reflection, splice loss, PMD. And then now if there's alarms in there, everything is going to be red or green. So here I got a bunch of greens and reds. There's no alarm for reflection because the number is in black. So if I say there's no alarms, now I got no alarms. Everything is in black. But every 1, 2, 3, 4, 5, these are UPC. They're all smaller, which is good, than neg 50, except one's at neg 47. So it's always arguable. Your engineering team, somebody from operations is going to say, put in these pass fails. But right now, if I had a neg 18, I call it a mud pie. I didn't plug in all the way. It's loose. So I should be fixing a neg 18 if it's at the patch panel, whether it's green or red. But that could be another session. Maybe folks don't know what an expected splice loss is, or the loss of a connector, or of a loss of a reflection. But if your folks are told what to use, then that's what we go by.
And Mike, there is a deployment guideline that Frontier has that's out on a web page, and that's been distributed to folks that are doing this right now. They've got that information, so they will know what to put in and what our standards are for everything.
And then Justin sent me a picture where it went. Picture right here. So this is for Justin. Was this from them or did?
Yes, yeah, this was shared at the last remote fiber characterization training. This is directly from Cisco.
So if that's pass and fail for PMD and CD, we can put it in there. Now everything is green. But the same way, reflection, you don't want to tell Cisco, well, Fiber Mike failed this or Fiber Mike passed this. Cisco and Frontier is going to have an agreement. We want all our connectors to be this. And if we get that information, we put it in the tester, and then everything's green and red.
I'm sorry, Sienna. Sorry.
Yeah, Sienna, that's Sienna.
Yeah.
That's what we built about 4 or 5 years ago. And we found a lot of anything that was a neg 50 or greater, we for sure went after it. And the majority of that was fiber locks in our network. You know, it was built a long time ago. So most of that time it was a fiber lock mechanical splice that we had to clean up. That clears it most of the time.
Okay, but yeah, if we see a splice has got reflection, then it was a mechanical, or it's a fusion splice going bad. But either way, if that mechanical splice is sitting a neg 28 and that's causing reflections and loss, then it just gets replaced. But if neg 50 was a number, we'd put it in there, and then now you get red or green.
Okay.
So for the overview, each machine has buttons, and up here, I'm in our remote control software. Because you only see my screen, now we have virtual buttons. So if I say to press the setup button and I press the button, the screen changed, but you didn't see what happened. So I'll move my cursor and say I'm going to press the results button. So if I press the results button, then we go to the results page. If I want to go to the home button, the cursor moves, my cursor's over the home button, I press the home button. So the home button is where our instruments are. Basically, if we touch an icon, it makes it yellow, it's active. Justin said we don't do an AP test today, so it's not yellow, it's not active. So if I want to do a test, I just touch an icon to make it yellow. The results page is where all our results are. So if I tap that hard key, I go to results, but down at the bottom, there's tabs. So we're going to do many tests, but there's only one results page. So in the far right, it says fiber complete. That's our term for bidirectional loss, bidirectional ORL. And then we call it fiber complete because the OTDR is on that same port. Most companies, or all the other companies, it's 2 modules or 2 testers. We combine them onto 1 port. Here's the MTOW. This is a switch. It goes back and forth. The automation page moves it back and forth. If I try to do a PMD test today, and that's all I'm doing, and I'm not using the automation page, my PMD test is never going to work because the PMD test is on port B, and right now it says it's on port A. Automation moves the sync back and forth automatically. Tab next to it is CD. Here's some CD results. Tab next to it is PMD. Here's some PD results. And then there's an OTDR tab. So I can press any one of these and go look at that particular result. If I go to setup, setup is the same way. There's setup for fiber complete. There's that switch. There's setup for CD. There's setup for PMD. And there's setup for OTDR. CD, there's a test auto button. It's always in test auto anyway. If you hit test auto, you never got to do CD setup again. PMD is test auto, so it's always in automatic mode. You never got to worry about it. And then for bidirectional loss on OTDR, that's going to come from the automation page. So we'll focus on that today. The file hard key, if we press that, this is like a Windows environment. We have folders. So the hard disk has 100 gigabits of space, a lot of storage. There's a disk, it's much smaller. So we go into hard disk. And then we create a folder over on the right. So now if I have a folder, if I highlight that, I can create a subfolder. And that could be a silly code. It could be by location. It's got to be something meaningful to you. So I'm just making up stuff and typing it. So if you had to test fiber characterization for the north route and fiber characterization for the south ring, you would just highlight it. And now you know you can go into the fiber characterization folder, and then you could find all your jobs because they're all going to be in one folder. I like to use AAA or quad A, so it's alphabetical. All my results go right into the first folder. So I got some stuff in here. I'll delete. But that's the basic overview. Setup. All the tests are basically in auto. Results. Press any tab to see the setups or results for that test. File is where our stuff is automatically going to get stored. And the home, if icon is yellow, we can test it. If it's not yellow, we can't test it. On the 8000, there's a blue button for fiber characterization script. That's the automation page. So I can press the blue button to get to the script, but there's also a FC script icon up here in the home page. If I press that, that takes me to the automation page. On the 6000, there is not a blue script button. So if we're on the 6000, we have to go to the home page, and then we have to use the FC script icon. So the 8000 has two ways, the 6000 does not. So if I hit FC script icon, it launches me. Then we pick the test we're going to run, bidirectional insertion loss and ORL. There's OTDR unidir, that means there's only in one direction. There's OTDR bidir, which means both ends run a OTDR, and there's OEO. Once again, that's not an industry standard. That means origin, endpoint, origin. That means we're both going to do a trace, but I'm going to take your trace at the far end and bring it to my T-Bird 8000. So here is full auto test. That means the data link is being used. Right now, mine is red, mine is off. But if I select OEO, it says we're going to use that data link. If I'm in bidir, I don't have to use a data link, but that means I run a trace, you run a trace, but your trace does not come to me. We said all the tests are in automatic mode. So if you have OTDR selected and you put auto, you get auto OTDR. That means it picks the optical settings just like a traditional OTDR has auto. So is this fiber 1 mile, 10 miles, or 50 miles? Where if you think you're on a 50-mile span and it's broke at 1 mile, it's going to see it short, change the settings, and tell you it's broke at 1 mile. So you can always use auto OTDR, and then you never got to go to the OTDR page. I use manual just for timing. I cheat and I do a 5-second trace instead of a 10 or 20 or 30-second trace. So we just picked the test we're going to run. If we turn off the machine, it all stays in the condition that it is, and you're ready to go. This is on the quick card, and this is in the video. Job type, it says cable or fiber. If you do cable, all results tested will go into one folder. So if I'm testing cable A and I test 4 fibers, I get all results in a cable A folder. If you're doing fiber span, select fiber, you get a folder per fiber. So if I'm in cable A and I got to test 4 fibers, I get a fiber 1 folder, a fiber 2 folder, a fiber 3 folder, and a fiber 4 folder. And I've had people argue, never select cable and never select fiber. I like cable because if you send me results, I have one PDF with all results in there. It's so easy for me to scan 10, 20, 30, 40 pages. But if you send me 24 fiber folders and you have all these different PDFs, I'm only going to spot check a few of them. But it's really personal. If you have to test 12 fibers, some folks say, Mike, I want to see 12 folders to know that I tested all 12. Here we put in our job info. It's looking for a cable ID and a fiber ID. So if you don't have a fiber ID, you could just type in the word fiber or something, building number, rack number, cable ID. I type the word cable, but if you have 1, 2, 3, ABC, or certain formats, for location, I had guys say, Mike, our format is building number, floor number, rack number, and they type in these long things. I'm kind of boring here. My location A, I typed in as A, and my B, I typed in as B. You have a choice for save PDF or not. And then you can start with your fiber number, 1, 2, 3, 12, 24, 48. And for direction, if I'm the A to B and the 8,000, the far in unit should be B to A. This one is a tip or trick. This says rate, and people will put that in. But what this really should say is PMD or CD alarm. And I put this into my software engineers just to make it easier to clarify. So if you pick 10 gig Ethernet because that's your rate, it's going to do alarms for PMD or CD. So if you want alarms from Sienna, then you would put user defined, and it's going to pull the alarms that you put for PMD and CD. And then once again, if you don't have to test for 3 weeks or 6 weeks or 1 or 2 or 3 months, this is recorded quick cards videos. We can do this again. And like Justin said, for out west, we did a webinar, so everybody got an initial introduction. So when we showed up, they know to have 2 cases. And I've done that before. We go to train and there's 1 case. I'm like, where's the other case? So this gives us an intro. And then when you got to test later, then we worry about follow-up to make sure you're ready to go. When you first come into here, there's summary results. This will be blank. So it says select results to display. You can pick 7 results. So I like loss and ORL and my 2 wavelengths. I like distance. I like PMD. I like CD. But you can just select them. I'll select CD and hit remove. I can have 7 summary results. This one is blank. So now if I select results to display, I can add CD. So now before I go anywhere, I see loss, distance, PMD, and CD. So if we're on a 32-mile span and loss is 8 dBs, 8 dBs, 8.1, 9, 7.6, if I get a 15 dB loss without looking at the OTDR loss test or anything, I got my total loss. I'm like, this is a bad span. So now I go over there and maybe we got that bad fiber lock mechanical splice, got a bunch of reflection, a bunch of loss, and now sooner or later we're going to have to fix that or replace that. So even without going anywhere, you can get a lot of information. There's a tester at each end, so you always get continuity confirmed. So I'll start in the semi-automatic mode. You see my data link is red. That tells me it's not connected, so I can't go full auto. If you want to go full auto, which is the preferred normal method, then that means your trace comes to me and everything is automatic. So I hit start on the 6,000 and I hit start on the 8,000, and then messages will come back and forth. Because this is semi-automatic because I didn't use that remote control fiber. So you want to test when we're connected? I hit yes. But because this is semi-automatic and we're doing this, I gave you 2 different looks. It forces you to look, see the same test a couple of times. A message is going to come up and I got to follow those commands. If it's full automatic, hit start and walk away. So you could go outside, go on the phone, text, email, call people, and then you could come back 4 minutes later and PMD, CD, bidirectional, OTDR, bidirectional loss, bidirectional ORL are all done and automatically saved. Normally loss at 1550 should always be less than 1310. It was higher. The only way that's going to happen is if there's a bend. I got a connection check. You notice this is good. If I plug into that tester dirty, I'm going to get a bad connection check. So we got our total distance. There's a big old 3 dB hit out here. So that's just a traditional. What the problem is, why is there a 3 dB hit out there at that distance? So we can tell by looking at that it's a bend, little loss at 1310, bigger loss at the higher wavelengths. Now it switched, it was automatic. It said the A guy was doing the OTDR, that's me. But now there's an hourglass, so I'm waiting and it says the B guy is doing an OTDR. And I didn't set this guy up to a 5-second trace, so he's taking longer. But for training purposes, I set it to 5 seconds because I still get a fairly decent trace, miss an event or two, and it just lets us go a lot faster. But during the testing, you'll see test results coming in, you'll see messages appear, you'll be seeing things move. I said I was the A side and the B side was called B. You might have Northtown, Southtown, CO, Ring, Hub, right? You're going to call your locations with specific names. A and B is boring, but it just lets you know you can name each side. So I'm in the semi-automatic mode. It's saying, hey, we want to do PMD testing, but because I'm not in full automatic, I got to go to the far end and I have to turn the PMD source on. If I don't, and I start the PMD test, it's going to say I have no light. So if I do it wrong, it just tells me. So at the far end, I put PMD and on. So it's doing stuff. I don't even have to know what it is per se because it's just going to spit out a digital number. Check CD source. On the 6000, I tap CD. Now it's on. I hit yes. So PMD, I don't know, was it 10, 15, 20 seconds CD? That might have just been a few seconds. It's pretty fast that I don't even time it. And even on a long span, it's still pretty fast. So follow this command. It says all fibers are done. Test next fiber, yes or no. My routine is I hit no, and then I go and I unplug from fiber 3 and I plug into fiber 4. And then I hit start. So you have your mojo, your juju, and your flow. I just do things always the same way. My one buddy was like, well, why don't you just plug into the next fiber and hit yes? That's not my mojo. I hit no, plug into the next fiber, and then I can hit start again. So we tested one fiber in the semi-automatic mode. If we go to results, CD just gives me a number. PMD just gives me a number. And we got OTDR. And then FComp gives us our loss at 1310, 1550, bidirectional average loss, and it gives us our ORL from each end. So it's like a traditional OTDR, right? Somebody said they just had an OTDR, but now I can go to PMD and CD. If I go to my file button, I had AAA selected. It created a folder called cable because that was my cable name. And now I got all my raw results stored. And then I got a PDF document automatically created. And if I open that PDF, I'll see OTDR, I'll see loss, I'll see PMD, I'll see CD. So this is one fiber, but I might have 6 pages. How many pages? I got a whole bunch of pages. So scrolling down, OTDR. There's bidirectional loss. There's PMD. So this is bidirectional loss. Here's PMD. This is basically a bunch of calculus to take these graph and spit out a number. But your Sienna and your network engineers will see the PMD is 0.2. That's good. We don't got to worry about it. And the same way with CD, it spits out a number, but it's per wavelength. So if your traffic is in the 1550 area or the C band, they'll look at 1550 and it has the total CD and the coefficient. So they'll look at that and say this fiber is fine, or we got to do some work. So there's a total dispersion and there's a dispersion coefficient. You and I don't have to know what these are, we turn them in. So all results in one PDF. If we go and do fiber next, they're all going to be in this one report right here. And we're still going to have all the raw data. And notice the naming. I said the cable ID was called cable, the fiber ID was fiber. So it's calling it cable fiber 3, cable fiber 3. So it's using that to auto name the results. So I'll go back to the script. This time we see the data link is red. So there's a data link test button. We can hit that and we can turn it on. So if I just connected to another fiber, notice this is data link connected is green and the fiber under test continuity is also green. So I tested 3, the script went to 4. That means you and I are on 4. If fiber under test is red, it means I don't see you. One of us is on the wrong fiber or there's a break. So we can now go shoot a OTDR. If the 30-mile span shows 20 miles on my trace, 10 miles on yours, then we're on the wrong span. Or they both say 30 miles, but we're connected to the wrong fiber. So we got continuity on the fiber under test, and we got continuity on the data link. And I'll try this. This just came back from a training class, and my adapter is busted on my talk set port. So I've been able to run the script sometimes, but sometimes I can't. I just need to get a new adapter so my data link stays in place. And then once you have data link connected, you can hit start at both ends. So now instead of doing bidirectional OTDR, we want OEO. So that way your trace comes to me. And let me see if I got a pass one stored. Okay, I passed it. So there's the A trace, 2/3 down the span. There's the bend. Here's the B trace. Unzoom it. There's a bend 1/3 down the span. And then here's the A and B trace. So you see in this direction, there's a big old bend. You see in this direction, there's a big old bend. Good looking trace, other than seeing this bend. And it's a 3.0 in one direction. It's a 3.2 in the other direction. The average is a 3.1. Your system could probably handle that, but if there's a bend, it's mechanical. Now the bend could get worse or it could get better. So to me, we see a 3 dB hit, right? It's like that mechanical splice with a bad reflection and or loss got to be replaced. Hopefully this is in a splice box so we can just go unkink it and get it all to work. So we go back to that script. And now I got full auto test, so I can do OEO. I got data link connected. I hit start on both machines. And this usually takes about 10 seconds. Then it'll look for the far end, and then it'll all start working automatically. So right now it says waiting for distance link. But I don't think it's going to sync up because I got to do some mechanical repairs on my adapter. But basically, if this is our setup, all you got to do is turn it on and enter the new job info for today. My cable ID is Northtown, or a silly code, whatever's meaning for you. We put in a fiber ID, location A and B, fiber number, and then maybe we're switching folders. This says I'm in hard disk AAA, so is all our results going in there? And then we have subfolders. So right, I had AAA cable. Now for today, I want to be in AAA, but I want to go to cable A or cable B or cable C. And on the script page, this is our courtesy reminder. All my results are going into AAA, and they're going to be stored in a folder that comes from the cable ID. So it's going to be cable. We already did that. So if I want a new folder, I'd call it cable A or cable BBB, next cable. So that's the automation page.
Yeah, I think that's a great point, Mike, that you know, once you do get the tests set up and thresholds in there to go from one job to the other, all it really takes is just renaming, telling the unit what span you're testing now, right? So that the folks, once the folks out on the West Coast got the unit set up properly once, that was it, and they're off and rolling. It's just a matter of changing names. That's the benefit of the automation.
And if we did get, like I heard the neg 50, you showed the PMD and CD from Sienna. If we get all that stuff, then we could name and save these configurations. So now, instead of me telling Schmitty out west or Johansson in Alabama that, hey, go and do this and go and do this and go and do this, then we could just load your configurations. So you don't have to do any setup. So here it says, press the load button in the upper right to load predefined test configurations located in this folder. So if you tell us pass fail for PMD, CD, loss, ORL, and OTDR, such as splice loss and connector loss and reflection, then we could email these to folks and they just use a USB, copy paste, put them on the machine, and then they just load them. So these guys here have not been specifically made for you, but this is just the example. Config. So here's one for CD. Here's one for OTDR. We can create them specific for you. And then now nobody's got to go to a PMD test or CD test to do test auto or do any of this stuff, because every little tiny setting, alarms, we can auto load it from you for one page. So resume running script. It says instrument status. If we hit load, then it's going to load PMD, CD, OTDR, bidirectional loss, bidirectional ORL to the exact test you want with exact pass and fail you want. So now we don't got to go to any setup pages at any time because it's all set up for you. And then that just ensures nobody messed up any of the tests manually. Maybe they're doing OTDR only, or they're finding some problems in splicing and they change the OTDR, where every time you go to the script, you load it, you got your exact settings, and then you just put today's job on fiber 48, cable AAA, location Northtown, location Southtown.
That's a shareable template too, right, Mike? Between kits.
Yeah, so we could just email it out and then we just tell them where to copy and paste it. So it says it's going into the configuration folder, into the FCAR for fiber characterization. So if we emailed it to somebody, we could type three sentences, edit copy, or you copy and then you paste. So if we paste, here's some defaults in here. What the heck is in here? I don't even know. These aren't mine. So I would create yours and I'd save it for CD. But right, there's CD, bidirectional loss, OTDR, PMD. So you hit load once and it's going to load all those tests for you automatically. And now we're guaranteed that everybody from the West Coast to East Coast is running the exact same tests with the exact same pass fails. And that just avoids us from having to go to a setup page, right? I said you could go to PMD and hit test auto. You could go to CD and hit test auto. You could go to OTDR and there's an auto button. So if somebody put OTDR to manual, right? If you put OTDR manual and you said the fiber stops at 20 kilometers, I've had somebody say, my fiber is broke at 20 kilometers because the trace stops there. Well, his fiber was fine. He told the OTDR to stop at 20 kilometers. So that could take minutes, hours, days to figure out. But now if you load a config, everybody's running the exact same test with the exact same pass fail. And we don't have to force anybody to go to a setup page and look at this and figure this out and find the auto button. So more of an intro today, right? Just to say, okay, the automation is easy enough, but you got to get to that point. So if everything is auto, we just go to the script page. We put in the job info right here. Hit start, get your PDF, get all those tests. So initially the first time, a lot of times if we're face-to-face, within an hour, we get everybody set up. I had some guys call me. I was in the car on the highway. I got them testing over the phone. So props to them. And if I didn't have something memorized, I go to this page. What's it say? Hit auto. So we have folks doing this over the phone. We have folks doing it via the web. We have folks doing it with video quick cards, and we have folks doing it with on-site. And then once again, whatever training is done, we still talk to people after, review these results. What about this? Or what about this? So is there anything else we should cover for today?
Okay.
But if it took you 3 hours to do your first job, because we're nervous, we haven't done it before, then the next one is down to minutes. And after that, we can pull up to wherever we are, pull it out, put location A, location B, new cable ID, and hit start. And we're just testing within a matter of minutes of being at that location. So it's just regular auto OTDR, except now we're throwing in auto PMD, auto CD, and then traditional bidirectional loss, bidirectional OTDR. So quick card, here is the script page, the stuff that we did, connections. And has anybody tested before with the kit? They have any comments?
Yeah, let me stop the recording here, Mike, if you got through the meat of it here, and we can kind of open up the discussion.